Most solar parks are ground-mounted PV systems, also known as free-field solar power plants. They can either be fixed, tilt, or use single-axis or dual-axis solar tracker. While tracking improves the overall performance, it also increases the system's installation and maintenance cost. Solar array. The solar arrays are the subsystems which convert incoming light into electrical energy. They comprise several of solar modules mounted on support structures and interconnected to deliver a power output to electronic power conditioning subsystems. Power conversion unit. Solar panels produce direct current electricity, DC, so solar parks need conversion equipment to convert this to alternating current, AC, which is the form transmitted by the electricity grid. This conversion is done by inverters. O&M building and SCADA system. Utility-scale solar power plants can present many challenges for a traditional SCADA system. A typical solar power plant contains thousands of connected devices from a variety of vendors dispersed across a large geographical area. A robust, scalable SCADA architecture, which can be quickly rolled out as new power plants are built, requires a lot of anticipation. Grid connection. The availability, locality, and capacity of the connection to the grid is a major consideration in planning a new solar park and can be a significant contributor to the cost. Most stations are sited within a few kilometers of the suitable grid connection point. This network needs to be capable of absorbing the output of the solar park when operating at its maximum capacity. The project developer will normally have to absorb the cost of providing power lines to this point and making the connection. Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.